Okay, so now that we have our DAG engine running quite nicely, let's go ahead and move our attention over to extending the ShapeNode class into our final data type classes that we would be using if we were to construct this whole thing as a truly functioning application. So let's go ahead and extend the ShapeNode class, if we look back over here into our whiteboard, into our geometry node class and our light node class. Now all we're really doing is simply putting the base class in place, if you will. We're not adding anything to it. Later on, if you want, you can come in and add all of the code required for it to contain geometry, or all of the code required for it to have light characteristics and perform light type functionality. Once again, we're just setting up, I guess you could just say, base type shape nodes.
Right,
okay?
We're just showing the next step for if you were to take ShapeNode and start using it as the basis for geometry nodes and light nodes.
Exactly. Okay, so with that, let's go ahead and jump over into Visual Studio, Logan.
All right.
And let's add in, let's go ahead and start with geometry.
Okay. So we'll go to classes and we'll add a new item. And the item will be a geometry node class. All right. With that added in, once again, I'll wipe out classes from the namespace. Then we'll jump down to geometry node, and we want geometry node to extend shape node. All right. Now, because it's a shape node, we have to satisfy the constructor. If we attempt to build, we get an error saying that there's no constructor for shape node taking in 0 arguments. There's no default constructor. So that means to finish off this this extension to shape node, we have to put in a constructor that will get a name from the user, which makes sense anyway. If you're making any kind of shape node, if it be a geometry node or whatever, you'll still want to feed in a name.
Right.
So that means we need to make a public constructor for geometry node. A public geometry node where we can take in a string name, and then immediately turn around and pass that name onto the base constructor as name, and then satisfy the opening and closing brackets. And now if we build, everything is happy.
Okay.
So that's really all there is. At this point, you could continue on and add whatever code is necessary to make the geometry node do whatever it needs to do.
Yeah, to make it a bit more focused on what the class represents. All right, let's go ahead and do the exact same thing for our light node class.
All right, we can go back to classes, add another new item, this time light node. And what do we do in light node? The same thing. Light node extends shape node. Light node needs a public constructor, so public light node, taking in a string name, and then calling the base constructor with the given name, and then our brackets. If we build, and we have a light node.
Outstanding. Okay, so now let's just create a piece of geometry.
Sure. Let's jump back to the program, and let's erase all of our example stuff. So let's start over, and if I can get the selection there.
There it goes.
All right. So we want to make, let's have a transform node, sphere node equals geometry node, or excuse me, equals new geometry node because we're creating one. So new geometry node, and then give it a name. And this could be sphere. Now, of course, we're storing a reference to a transform node, so I'll have to have that geometry node dot transform node, just like we had done in the past example with the remove testing.
Right.
So we'll actually store the reference to the transform node.
Because both the geometry node and the light node are inheriting everything from shape node, which means that it is inheriting the transform node.
Right. Which also means if we were storing shape node references, obviously we could store just this portion of the return and not have to get the transform node out of it.
Right.
But that looks like it should work for a sphere. So let me copy, duplicate that line, and let's make a light node. And that light node should be equal to a new light node object. And let's call that light node light, or even better, spotlight, because I seem to remember that being written on a whiteboard somewhere. So we have spot light.
Okay. Now let's take our two newly created transform nodes and group them together.
Okay.
So we can group sphere node and light node.
So we'll call upon transform node and tell it to group, it's both of them. So light node and sphere node. And there we go with sphere node. All right.
And then let's just do a show off from our transform node.
Alright, transform node, show all. We still have our console read line, so let's run.
Alright, so there is our group transform node. Of course, it has no associated shape node. And then parented to it, we have a spotlight and a sphere. And the spotlight has associated to it the spotlight shape node, and the sphere has the sphere shape node associated to it. Perfect. That's exactly what we were looking for. So with that, we're now in a position where we need commands so that we can really start working with the engine. The engine's there, but you'll notice Logan's have had to continue to come in here and just hard code all of this stuff. But at this point, we need to get the command portion up and running so that we can simply just start typing in, create this node, create that node, group them, parent them. Let's get a quick listing of how the hierarchy looks. All right, well, let's unparent this. Let's rename this. Let's get all of this stuff in place. So we need to get some sort of command architecture going. So with that, that is going to wrap up the engine itself in regards to the DAG hierarchy. And we'll now be shifting our focus over to the command system. So that's going to wrap up this video. Thanks a lot.